2004 Indian Ocean earthquake was extremely catastrophic. The earthquake hit at just before 1 a.m. on December 26, 2004. The relatively shallow water where the earthquake struck meant the energy released was equivalent to 23,000 Hiroshima-type atomic bombs. It was the third strongest earthquake since recordings of magnitude began in 1899. A rupture at the USGS estimates that it was more than 600 miles long, displacing the seafloor above the rupture by perhaps 10 yards, horizontally and several yards vertically. It had an epicenter off the west coast of Sumatra, India, and the magnitude was measured around 9.0, but has been increased to 9.1 and even 9.3. It is the second largest earthquake ever recorded on a seismometer.
A tsunami was a result of the 2004 Indian Ocean earthquake. A tsunami waves radiating from the earthquake zone slammed into the coastline of about 11 Indian Ocean countries. It was the world's deadliest tsunami, with over 230,000 people killed and about 500,000 injured by the waves. The wave itself was only about 0.5 meters high, but it was extremely long. It was about 500,000 meters. The waves had reached up to 65 to 100 feet in some areas. The waves traveled at a speed of a jet airliner and at speeds up to 500 miles per hour. It was traveling with so much energy and went as far as 5,000 kilometers to Africa. The estimated cost of the damage was just under $10 billion. It was an extremely high casualty rate.
The first thing you want to do when making a graph is make sure your scale begins on the y-axis so that your scale is worth 1 unit. Secondly, you want to take a look at your data for distance so you can accurately find the radius. Then you want to place 3 points over each of the city that you want to use for your graph. And from here, you can determine the equation for all three. To convert miles into the radius, you simply cross cancel. You should get a graph like this. For our second graph, we used a slightly different method. We ended up getting the same epicenter. Instead of using the city of Banda Aceh, we used Bangkok in Thailand. The 3 coordinate points we got are 8.4, 0.9, 6.4, 3.4, and 6.75, and 6. 3 arcs squared, we got 0.68, 3.42, and 9.73. So this shows you that although you can use different methods, you should get the same location of the epicenter if you have the correct data. In modern times, geologists use devices known as seismographs, which are an instrument that measures and records details of earthquakes, such as force and duration, by slight earth vibration. They also use things called P-waves, which helps them determine the arrival time minus the origin time and the interval instead of distance. So there's 2 scales. They also use a method known as triangulation, which is the tracing and measurement of a series or network of triangles in order to determine the distances. So they essentially use angles to help them determine where the earthquake originated.